Hi, I'm Neuhaus. I'm a researcher at the Experience and Interaction Workgroup at the University of Siegen in Germany. Together with my co-authors Ronda Ringfort-Felner, Courtney, Madlen Kneile, and Marc Hassenzahl, I wrote the paper Virtual Unreality Augmentation-Oriented Ideation through Design Cards, which I am presenting today. When developing applications for VR, a primary goal is to use the possibilities of current VR systems to create experiences in the virtual world that are visually and in their interactions as indistinguishable from the real world as possible. Basically, the most common goal is to maximize realism or naturalism. Pursuing realism is of course a valuable design goal. It can make engagement with the virtual world more intuitive and immersive, but it can also come with some downsides and complications, and technological limitations will likely keep VR applications from reaching full realism for a long time, if that goal can ever be really achieved. A complementary approach I want to showcase today is to explicitly focus on what you can do in VR that is not easily possible in the real world. In VR, users can experience impossible and augmenting abilities like telekinesis, unrestricted or super-fast movement, or changed perception. A growing body of work already explores these virtual abilities under terms like magical or hypernatural interactions, beyond real interactions, or superpowers. This quote by Saderian and Hassenzahl sums it up nicely. The real benefit of using VR may not necessarily lie in improving an imitation of reality, but in cultivating the unique possibilities of VR to augment human capabilities. There is potential of using VR to make users experience things that are impossible in the real world, or as we call it here, virtual unreality. But so far, there are no guiding tools and methods to help designers make use of this potential. Therefore, we set out to develop a design tool to inspire and guide ideation and development of VR applications making use of this unreality. As a brief overview, we first collected work on virtual augmentations in literature and conducted interviews with experienced VR users about positive and augmenting aspects of VR, and on that basis developed a set of design cards that contain 15 augmentation opportunities in 5 categories to support ideation of augmenting VR applications. We then conducted 5 ideation workshops in which we used the cards with groups of designers and developers in the early stages of development for serious VR applications. Finally, we analyzed the workshops and their results, as well as interviews with workshop participants. While of course everything is described in detail in the paper, in this presentation I want to focus on showcasing the design card set, how we utilized the cards in the workshops, as well as key insights from our analysis of the workshops. First off, I want to briefly talk about why and how we made the card set. Several authors acknowledge a lack of design tools specific to VR. While established human-centered and participatory design approaches can also be applied well in VR development, they do not support designers in specifically making use of what VR has to offer. So we wanted to make an easy-to-use design tool that helps designers to make use of some of the unique opportunities of VR. Also, design cards are an established tool to summarize frameworks and methods and to use them in design processes. Design cards can be good at facilitating discussions, at expanding the design space, and at providing a common reference for interdisciplinary teams. Openly designed cards can be used flexibly and make design processes fun and engaging. As a basis for the design card set, we had 2 main sources of content. We collected already implemented augmentations from literature, and we conducted interviews with experienced VR users and developers. In the collection from literature, we largely followed Raisamo and colleagues' classification into 3 main forms of augmentation that also apply to VR: perception, action, and cognition. Perception augmentation involves enhancing or altering senses such as vision and hearing, enabling features like expanded field of view, zooming, or even echolocation. Action augmentation introduces new modes of movement like superleaping, flying, or telekinesis, along with innovative haptic feedback methods. Cognition augmentation includes providing timely information and memory extension. However, we also found some examples that do not directly match this classification. Augmentation can also extend to areas such as body ownership, basically representing yourself differently in the virtual environment. Our overview shows that many examples of virtual augmentation exist, but rather as explorations or proofs of concept. However, many of these examples can be good inspiration in the beginning of a design process. To expand our collection of augmentations and to understand the consequences of virtual augmentations more in depth, we conducted 8 interviews. We recruited participants who interact with VR on a regular basis, use numerous VR applications, and in most cases use it or develop for it professionally. The interviews added to the collection of augmentations in VR. Among other points, the participants mentioned that especially the virtual world itself could also feel augmenting, as physics work differently and everything can be easily customized. It can also provide exploration opportunities at low stakes. Additionally, participants appreciated the ability to slip into different bodies in VR, affecting their sense of self and decision-making. Overall, the interviews confirmed and expanded the augmentations found in literature, but also provided subjective insights into the user experience of feeling augmented through VR. The results also emphasized the importance of both personal and environmental augmentation in VR. We combined the results from literature and the interviews for an overall collection of 15 augmentation opportunities in 5 categories. The categories include augmented worlds, which highlights possibilities of the virtual world to be augmenting for the user. Virtual worlds follow completely different rules, can be transformed easily, contain objects that would be impossible in the real world, and can represent safe spaces for exploration. An extended self highlights how users can change themselves or be changed to make new experiences. One can take on roles of others in VR, not only as role play, but also in terms of abilities. One can change one's own shape in terms of appearance and other features, and one can even be several things or in several places at once in VR. Augmented actions describes different possibilities of abilities, such as powers that concern strength, telekinetic abilities, movement abilities, and teleportation. But the environment can be even influenced in more ways, such as manipulating the passage of time actively. Enhanced perception offers possibilities of perceiving beyond natural abilities, for example by seeing and hearing from different perspectives at the same time, or magnifying perception. One can select focus points, filter out stimuli, or switch off senses altogether. Finally, augmented thinking describes cognitive augmentations like expanding memory and accessing it automatically at a fitting time. For each of these augmentation opportunities, we now created a design card from our data, following a structure we developed based on information that is helpful at different stages of a design process. Each card starts with a title and brief description that should be easily understandable. In quick ideation sessions, this can already be a sufficient starting point at times. Then, the cards describe the augmentation opportunity further. Possibilities describe what this augmentation allows users to do. Design prompts offer specific questions to support designers or developers when creating ideas. Feelings describe emotions that the augmentation can trigger. The quotes extend a more human feeling of what the augmentation can lead to. As you can see, we also added symbolic 3-dimensional illustrations to help spark creativity without being too leading. Of course, I would like to go over all the cards in detail, but while there's no time for this here, you can find the cards in the appendix of the paper and also as supplemental material. We believe the cards we created can be used in many different ways and during different stages of the design process. The design of the cards was strongly influenced by insights from literature about card-based design. For example, we kept the cards open so they can address different domains and types of applications. The different contents should offer various starting points for inspiration and association. After the development of the cards, we used them with different groups of designers and developers working on real VR applications to evaluate their usefulness and to learn more about ideas and concepts they can lead to. We used the card set in 5 workshops with groups of participants of various backgrounds. Each group was in the very early stage of developing a VR application for a different domain. Domains were very diverse. For example, one group was developing a VR application to experience stage performances, such as concerts or plays in VR, while another developed an application for performing physiotherapy exercises at home. The participants were from very different backgrounds and included developers, interaction designers, but also practitioners from the specific domains. In total, 34 people participated in the workshops. All workshops comprised 5 key stages. Participants first presented their project, discussed and collected goals, the scenario, and initial insights. Then we introduced augmentation-oriented design and the card set. To use the cards, we conducted a speed ideation. Participants quickly generated ideas for augmenting VR applications by pairing insights on their scenarios with the design cards. Afterwards, promising ideas were selected and developed further through enactments. Participants acted out the future use of envisioned VR applications in improvised role-play, facilitated by placeholder props. Finally, participants reflected on the workshop and outcomes. Participants found it fast and easy to develop concepts when using the cards with the goals and insights from their scenario and domain. In this quote, one participant said, "I mean, like it's always super easy, just taking this insight and then reading through it and thinking. It was cool how almost from any card and any insight you could come up with something, and so it really helped with it." Some thought it was sad that the short time during the workshop did not allow them to use and explore all cards fully. The participants we interviewed saw the concepts they developed as the most important outcome of the workshop and thought they were innovative and new, something they would have otherwise not thought of. However, we noticed some tension. While some participants preferred simple concepts and were afraid of too many augmentations or a virtual world that is too different from the real world, others felt that such a workshop should be the ideal time and place to explore crazier ideas. Overall, the cards and the workshop were seen as helpful to more directly question when and where to focus on realism and how to make the most of VR. Another quote, "It was important for us to bridge the gap between VR and reality. For us, this has expanded the process at ideation a bit more, that you look further and think about how much more is really possible in VR." I want to showcase just a few of the concepts the participants acted out during the workshops. For example, the generational magic garden, in which a grandparent and grandchild can have a virtual gardening experience in a VR garden where they can plant and grow anything they want. The grandparents uses their real-life gardening experiences augmented by additional knowledge provided in the application to help the grandchild become a master gardener. The avatar of the grandparent has easy movements to enable them to perform actions they physically might not be able to perform otherwise. Further, they control things like the weather using a magic wand. Another concept is movement training with the doppelganger, a VR application to learn and perform exercises from physiotherapy at home. The user's virtual avatar is duplicated, so they see a copy of themselves in front of them mirroring their movements. This way, the user can see how they perform the exercises, and the application provides direct visual feedback to improve motion accuracy. If the user's form is incorrect, symbols indicate where improvements are needed, and anatomical views show why the posture should be corrected. The user can also walk around the avatar, view movements from all angles, and control the speed to focus on specific aspects. Using interaction criticism, we also took a deeper look at the concepts, focusing on how the participants used virtual augmentations in their concepts for the application's intentions. We found two main patterns of applying augmentations in the concepts. Some concepts focus on exploring the general possibilities of the virtual world and are often a bit abstract and theoretical without detailing specific interactions. At times, these concepts also appear a bit more fragmented and are rather explorations of what could be possible with virtual augmentations in the specific domain. Other concepts purposefully apply augmentations to support the overall goals of the application. In these concepts, the aim seems to be to generate value by closely intertwining augmentations with the application's objectives. With this approach, augmentations are selected and shaped specifically to enhance interactions and provide meaningful experiences or offer new insights to users. Overall, closely aligning augmentations with application goals seems to be a favorable approach, as it enhances the potential for persistent value creation beyond technological novelty in VR experiences. However, we believe that also the other concepts that may appear fragmented or challenging to implement can contribute valuable insights during the development process just by exploring what is possible. To summarize, participants in the workshops found the design cards to be helpful in generating new and innovative ideas for VR applications. The feedback from the participants and requests to use the cards in other projects suggest that the cards can bring value to a design process and open a new perspective in ideation processes. While the approach led to innovative ideas, there were concerns about potential drawbacks of augmentation-oriented designs, such as difficulty in learning and using them, especially for inexperienced users. Further studies comparing augmentation-oriented designs with realism-oriented designs are needed to better understand their impact. Despite challenges, there's potential in moving beyond realism in VR design to offer users unique and engaging experiences. I hope I could interest you in using the cards and in the overall approach of virtual Unreality. Of course, there are more results and discussion points in the paper. I am happy if you reach out with thoughts and questions on the topic.